So the extra practice component of section 4.1, in the first problems, we have two things to do. We have to name the vector and then write its component form. My vector is M as the initial point, N as the terminal. So I'm going to write it as MN with my vector notation over the top. And the component form for the vector gets into how do I slide to get from M to N. And I'm going to always be looking to go left, right first. And I'm seeing that as a slide to the right of 4. All my X values would be increased by 4. And all my Y values would go up 1, 2, 3, 4, 5, 6. So my component form has to do with how I'm sliding left, right, and then up, down. Now my vector for number 2, my initial point is B. The arrow shows the direction I'm going. So my vector for 2, I'd name it as B to A with my vector notation over the top. And then my component form, to get from B to A, I'm going to have to go left 5 units first. I'd represent left 5 as a negative 5. And then I'd have to go down 1 unit, so the component form would be negative 5, negative 1. Naming number 3, my initial point is K. So when I name it, I'm going to write it with K out front. It's going to J, my vector notation over the top. And then I go figure out how I get there. From K to J, I'd have to move 1, 2, 3, 4, 5 units to the right. I'm sorry, that was left. Negative 5, comma, and then I'd go up 3. So this one was negative 5, negative 1, negative 5, and positive 3. So 2 things, naming the vector, writing its component form. That's it for that. Turn it over. So feeling good about that, you just moved into some of the high school stuff. All right, now, taking my pencil, and then I'm going to actually use different colors to perform all this. In 4 through 7, please stop talking. In 4 through 7, the vertices of the triangle are given. I want you guys to notice as you're graphing that this grid is going up by 2s. It's going up 2 units every time. So to graph the point 1, 2, I'm going to be right here for A. 5, 1, 5, and I'm going to be in the middle here for B. 5 and 4 is going to put me here. So this is what I'm going to call your pre-image, where we start. So my pre-image is defined on my drawing, ABC, and then I've got 4 different vectors. Yep, pre-image is part of your definitions. So my pre-image is the original triangle, and I'm going to keep going back to that pre-image, and I'm going to translate it based on each of the different problem numbers. So what I have here is I'm going to pick up these vertices, and I'm going to move them 4 units left. And that's it. I'm going to take every X value minus 4, and the Y value stays the same. Every X value gets moved 4 units left, but the Y value stays the same. So number 4, I'm doing in pink. I'm going to move 1, 2, so that's 2, 4, 2, 4, 2, 4 units. And if you guys grab different colored markers, you might not have to like it. I think our drawing might wind up being a little bit better. If you grab different colored markers, I think your drawing might wind up being a little bit better example to refer back to later. So once you've got number 4 done in one color, every single time we're going to go back to the original image ABC, or the pre-image ABC that I shaded in. In number 5, I've got to move all my X values 2 units left. My Y's all have to go 4 units down. So every point on this triangle has to go 2 units left, which means I'm jumping, and then 4 units down. 2 units left, 4 units down. 2 units left, 4 units down. So my number 5 lands right there. I'm going to grab a different color for number 6. Number 6, my x values are all going to stay the same. My figure is going to move down 5. My component form's got a 0 there. So I don't move anywhere left or right. I got to pick everything up and go down 2, 4, then 5. Down 2, 4, 5. It sits right there. 2, 4, 5. It sits right there. Now I think the one thing here that might just be giving you a little bit of a headache is that our grid is going by 2s. I'm going to be moving up 1 and left 3. I'm sorry, right 1 and down 3. I'm going to be moving right 1 and down 3 for the last one. Right 1, down 2, 3. Right 1, down 3. Right 1, down 3. So my last one winds up here. If we didn't have a coordinate grid to put these on, we could just do the math on all the points. If I needed you to show me what the coordinates are, honestly, I'd probably go do the math on the coordinates rather than trying to pull them off of the graph itself. Now, as we move on into number 8 and 9, it's saying write a rule for the translation. Write a rule for the slide. So what I'm noticing in number 8 is that this whole figure, and I'm going to actually draw like the arrows. So that's my vector I got to slide on, and if I drew it for every other point, it's exactly the same, isn't it? Bless you. See how all those lines are parallel? So we were getting to that in our notes. Now let's talk about this vector and go left, right. So I just actually drew in 4 vectors. They're all exactly the same. They're all exactly the same. How do I get from P to P prime? What do I do going right? How many units right do I have to move P? Looking at 4. I heard that from somebody. Then up how many? I think so. Does every point get moved 1, 2, 3, 4, up 3? You got it. 1, 2, 3, 4, up 3. So it's not telling me to write this in vector or component form, but it would look like this. Or we could say take your x comma y, and it would be x plus 4, y plus 3. Try number 9. I'm going to work through it and write on my paper, but I'm not going to talk through it. And you don't need to draw all 4 vectors. Find one. No. Well, I just did that wrong. Would you move every point right 1 and down 3? Right 1, down 3. Always left, right first. Right 1, down 3. Always left, right first. Oops. Before I go on, what questions might you have? Mark. So I'm trying to describe how it's sliding. And so as I'm describing how it's sliding, I'm always looking for if I want to get from a pre-image to an image point. How do I get there if I have to walk and do left, right first? I'd have to go to the right 1 unit. That's where this came from. Then I have to get to here. I've got to go down 3 units. That's where this came from. Let me go back over to 8. I want to get from P to P prime. If I'm going from P to P prime, and I have to go left or right first, that's where I was going right 4. That's where this number came from. Up 3. That's where this number came from. So it's like, they call it, I've read this in algebra books, they call it like as the crow flies. You can fly from P to P prime, but really you got to walk around the blocks. You know, like I think about back in the day when I was living in my neighborhood where I grew up, it would be so much quicker if I could walk to my best friend Dawn's house by going through people's backyards, but I didn't. I couldn't. I'd get yelled at by this mean lady. I had to walk around the blocks. So you're defining the blocks, left, right, first, and then up, down. I've always got some ridiculous story, don't I? So Mark, if we're not in a drawing, what do you think I'm going to do? So this is the translation. I'm moving on to 10, you guys. This is the translation that I have to perform on this point. Mathematically, I know you're strong in algebra. What do you think the end result would be to get to J prime if I had to do this translation on this point? Take your x value and add 6 to it. Not 8. Take your y value, subtract 3 from it. So I'm getting this by doing 4 plus 6. That's where I got my 10. Now I'm going to go take this 5 and I'm going to subtract 3. So my new image point of J would be 10 and 2. I added 6 to the x value, subtracted 3 from the y value. Do the same thing. Ooh. Now, this one's interesting because they're saying, what's the image of JR prime? I'm going to call it R double prime. We must have moved from some R to get to here. What's going to happen to 0 when I go right 6? What's going to happen to negative 5 when I go down 3? Negative 5 minus another 3 is going to take me to negative 8. Now, this drawing is really weird. This drawing is really weird. Where's the spaceship? Where is the spaceship? Is this the spaceship? I thought it was in the origin. This video game, you move a spaceship 1 unit left and 4 units up. Then you move the spaceship 2 units left. This drawing is terrible. This drawing's terrible. Let's just skip the drawing here. I don't even get what they're trying to say. Let's start here. Let's say that our spaceship, and I kind of wanted it sitting at the origin. Let's say the spaceship sits at 0, 0. You guys okay with that? Let's just like call it starting at the origin. So now they're telling me to take this spaceship and go 1 unit left and 4 units up. So my xy is going to become x plus 1, y plus 4. So what's my place that this just got to now? What's 0 plus 1? What's 0 plus 4? That's where it moved to. And then it goes on and says, then you move the spaceship 2 units left. So now I've got to take the xy that I have right here, and I've got to move it 2 units left. And the y stays the same. It didn't tell me anything up, down. So where did the spaceship wind up?
Why did you put?
Hold on. Negative 2. No. I'm moving from here. I'm moving from here. So I'm landed here, and I'm moving down 2, so that takes me to negative 1, and staying at 4.
So it got bigger?
It didn't get bigger. It just slid around. It first went... Wait a minute. Shouldn't this be minus?
Yeah.
This should be minus. 1 unit left. Sorry. Then you moved 2 units left. This one's okay. So this should actually be negative 3, shouldn't it? Sorry. This was 1 unit left, and I wrote it as a plus. Good. Who caught that?
Dominique.
What?
Somebody did. I heard somebody talking about it. So then I got here. Now, this is when we do one thing followed by another. This was our first move. This was our second move. This is called a composition. When we do one move followed by another one, it's called a composition. When we combine transformations, it's called a composition. That's going to be one of your vocabulary words. When we define transformations, it's a composition. The question about this is, can we rewrite where we started to where we ended in one set of directions? To get from 0, 0 to where we ended at negative 3, 4, What would I do to the x values? Take what? What am I doing to the y values? So this wasn't a real easy process because in this video game, I moved the spaceship 1 unit left, 4 units up. Then I moved it again, 2 units left. Rewrite the composition, first and second, as a single transformation. Here's my single transformation. Where I started, where I ended after the two slides. And here's the single transformation answer.